Hi Year 10, this is the first in a series of videos I'm going to do for the topic of functions. In this first video we're going to look at functions and relations. So let's begin by defining a relation as just a relationship or connection between variables. So here we've got a set of x values and we've got a set of y values and we've got some connection between them. Okay, so this is a relation. A function is a type of relation. It has one special condition, and here it is. For any input, there is at most one output. So if we consider these to be the inputs for the function and this to be the outputs, for any x that I put in, there should be only one answer. Okay, so 1 here is mapping to 31, 2 is mapping to 16, 3 is mapping to 5, and 4 is mapping to -4. So this is a function. Now I mentioned inputs and outputs. A function has an independent variable, that's the input, and a dependent variable, that's the output. It depends on what has been put in. And you can look at it like a machine, if you like. So we put in some numbers, it churns around in here and it spits out an answer. And you can see that this is a function. For any number that I put in, there is at most one answer that comes out. Now there are different representations of functions and you need to be familiar with all of them. Here's the first one, the idea that we map from one set to another. We have an input set, we have some kind of function that maps each of the elements in this set to an output set. Could be written as a set of coordinates. The x's are the inputs and the y's are the outputs. It could just be written as an algebraic equation, like y equals 2x squared plus 3. For any value x we put in, we get a corresponding y value. Or it could be represented graphically. So let's return to this idea of what is a function. Remember we said a function is a relation, it has a special rule. Here's the rule, for any input there is at most one output. Now at most means 0 or 1. So let's have a look at this one here. Is this a function or not? 1 maps to 31. 2 and 3 both map to 16. And 4 maps to -4. So for any input, there has to be at most one output. It is a function. Now, even though 2 and 3 both map to the same number, they only have one answer. Does that make sense? How about this one? So we've got 1 mapping to 31 and -4, 2 maps to 16, and 3 and 4 both map to 5. Okay, this one is not a function because for this entry here, or this input, we get two answers. Do you see that? Okay, same question, but different representation. We're going to look at the ones with coordinates. So which of the following are functions? Now basically what we're looking for here is there only one answer when x is equal to 1? Is there only one answer when x is equal to 2 or 3 or 5? And there is. Each of those is unique. So this one is a function. What about this one? Can you see straight away that one's not? For the same input of 1, I've got two answers, 1 and 0. This is not a function. How about this one? This one's fine. I know it looks confusing, but for any input, 1, 2, 3, or 5, I get at most one output. Even though it's the same output for all of those, it doesn't matter. And this one's not a function. Okay, so here we've got the same input, 1, 1, 1, 1, with 4 different answers. So not a function. Now it's easy to tell if a relation is a function if you're given the graph. Here's the rule. Any vertical line can cut the graph in only one place, and this is actually called the vertical line test. Let's have a look. Here's a parabola. We can tell this one's a function. Any x value is only going to give me one y value. These dotted lines are the vertical lines, and any vertical line that I draw is only going to cut this graph in one position. But this one's not a function. Can you see that? There's heaps of places where if I draw a vertical line, I'm going to cut the graph in 2 places. So this means when x is 4, I'm getting 2 answers, 2 and -2, not a function. Now finally, if we're given an algebraic equation and asked if it's a function, we could graph it, but if you don't want to graph it, there are a couple of things to look for. Firstly, a plus minus sign is a dead giveaway. Look at this, if I put 2 in here, an input of 2 gives me 2 answers, plus or minus 2. Not a function. A term in y squared, because when I do the square root of both sides, I get plus minus, so we're back to this rule. Or no term in y, like this. This is a vertical line through x equals 9. So it breaks the rule all over the place. It has an infinite number of outputs for one input. But we can show algebraically that x equals y squared is not a function. All we have to do is make y the subject. So let's turn it around. Y squared is equal to x. Take the square root of both sides. Don't forget your plus minus. So y is equal to plus or minus x. Now all we need is one example to show that it's not a function. We don't have to prove it for every number. So let's pick one. Let's pick x equals 1. So when x is 1, y is equal to plus or minus 1. 2 outputs for one input. Therefore, x equals y squared is not a function. Okay, that's the end of this lesson. In our next lesson, we're going to look at function notation.